So we'll have a little bit of a look at hyperbolas. So the next little bit of today's lecture is just going to be, I guess, a focus on some of your specific function types that you need to know of, and that you need to be able to sort of use and manipulate, doing a whole bunch of different things. But we're going to look at each of them together. So the first function we're going to start with is your hyperbola. Some schools and some textbooks will also refer to this as the graph of the reciprocal. So if you see it written like that, that just means hyperbola. And so a hyperbola is a discontinuous function in the form xy equals k or y equals k on x, where k is a constant value. So essentially what that means here is that if we have a discontinuous function, pretty much just means there's two segments of our function, and that there's going to be some values for x or y. With a hyperbola, it's talking about x, but discontinuous can also mean y, where the graph doesn't exist. Okay, so there's going to be some values for x where our graph cannot and will not exist. Now, these equations may look a little familiar, xy equals k or y equals k on x, if you remember doing inverse variation. So these do look like the equations for inverse variation as well. Discontinuous function means your function is not a continuous curve. There's at least two segments to it. Some graphs will have more. And so when we're looking at a hyperbola specifically, our graph is in the form of two discontinuous curves that have asymptotes in the x and the y axis that they cannot cross. So an asymptote is essentially just a line which your curve will approach, but it will never touch. So looking at this graph of a hyperbola here, we can see that this is just the basic graph of y equals 1 on x. So that's like your basic hyperbola, kind of like how if you had a parabola, like your basic parabola is y equals x squared, your basic hyperbola is y equals 1 on x. And so essentially at that point, your asymptotes exist at x equals 0 and y equals 0. And your graph will never hit those 2 points if you just have the basic hyperbola. And then your asymptotes will change as you change your hyperbola. So as you move it up, down, left, right, dilations, or anything like that, you will change your asymptotes as you change your function. So, looking at some more specifics of our hyperbolas, if your k is positive, then your curve is going to exist in the first and the third quadrant. So I'll show you guys this example graph here again. Remembering, whenever you do maths, your quadrants are labeled 1, 2, 3, and 4. Okay, starts in the top right, goes anti-clockwise. Okay, this will come back when we look at trig. When you do some stuff with trig, your quadrants in trig are also labelled as such, 1, 2, 3, and 4. So if our value for k is positive, so if we have a positive constant, then we are going to have a graph in the first and the third quadrant. If k is negative, then our graph is going to exist in the second and the fourth quadrant. Then when we're looking at our equation again, the larger our a is, that means the further away the curve will bend from your asymptotes when we're looking at the equation in this format, y equals k over x minus a plus b, where a and b are the transformations you can do to your graph, where it'll move it left and right, up and down. Okay, so similar to moving any other graph, if we have x minus a, this is moving our graph left and right, and then the plus b is moving it up or down, depending on the values for a and b. So the bigger a is, the further away the curve is bending from the asymptotes. Okay, when we have our graph in this format, our asymptotes, our x asymptote is equal to a, and our y asymptote is equal to b. Now, the reason for this is because we can never have our bottom of our denominator, bottom of our fraction, or also known as the denominator, can never equal 0. So x minus a can never equal 0, so therefore x can never equal a. The reason that b becomes the y asymptote is because our original asymptote occurs at y equals 0. So if we move it up or down, we're essentially just moving that original asymptote with us. Okay, so another example question for you guys to have a go at. I'll give you maybe a minute or so. Have a look at this question, see if you'll be able to graph y equals 5 over x minus 2 minus 3. And then we'll go through it in about a minute. If you need more time, you can just pause the video as well. So I'll just give you about a minute to have a go and look at this question. Alrighty, so looking at this example question, first thing we want to do is rearrange our function so that we can work out where our asymptotes are going to be at. So we can see that our asymptote here is going to be is going to be 2. So our a value here, and then our y asymptote is going to be at -3 because in our original function we've got our asymptote at -3. Our value for b at -3, which means the asymptote is then going to be at -3. So from there, what we want to do is find our intercepts. Now, hopefully by now, you've had a lot of experience finding intercepts. So we find our x-intercept when y equals 0, and our y-intercept when x equals 0. So that's going to give us these two coordinates as our x and y intercepts. So once we found the asymptotes and the intercepts, we're ready to sketch our graph. Okay, so hopefully you guys have had a go sketching. So we end up here with this graph. So the first thing we do when we sketch is always plot in your asymptotes. Draw them as, or they're usually drawn as, and how I like to draw them is just as dotted lines. Make sure you use a ruler so that they're accurate, and we want to make sure that they are to scale. So first thing you want to do, draw in your asymptotes. Second, we want to be working out which quadrants is our graph going to exist in. So remembering that your quadrants are going to be relative to your asymptotes, okay? So if we're looking at these green lines here, this creates our new 4 quadrants. So we've got 1, 2, 3, and 4. Okay, so all of this, even though some of it is above the x-axis, some of it below, all of this makes up quadrant 1, all of this quadrant 2, quadrant 3, and quadrant 4. So going back to our original equation, we can see that we've got a positive value for k, so our graph exists in the first and the third quadrants. Then we just want to plot in our intercepts, so our x-intercept, our y-intercept, and then we just want to draw our lines for our hyperbolas going towards both of our 2 asymptotes. Just like that for hyperbolas. So hopefully that made sense. And yeah, we're going to have a go.